Welcome to the channel. This is Waga. We are going to do another Leetcode question, and the question in question is O of n. Is number 76. Minimum window substring. I was just checking the. Could you find an? They want you to do it in O of n, right? So we are supposed to find the minimum window which contains all characters in S. You're given a string S and T, so you're supposed to find the minimum window that contains all the characters of T, and you're supposed to find them in S, right? So in this case, we are supposed to go through all this and return blank because that's the minimum window, right? Yeah, so basically that. So let's copy our code. So we could come here and say we're going to work on what, because we need to create a few things. So we could say S is going to be the string we want to work with, and it's going to be ADOB, Adobe, CODE, and then BANC, and T is going to be, this is lowercase s, right, and this is lowercase t, like so, and this is going to be ABC, right? So the first thing we want to do is we're going to use two hash maps and a bunch of variables, right? So the first variables we are going to have is going to be the have variable, right? And this one could be 0, and the need variable is going to be 3, right? The need variable is going to be the length of t, the number of letters we need, right? And after that, we're going to have two hash maps, right? And the hash map is going to be, there's going to be one hash map for our window, and then another hash map for the actual appearance of the characters that we're going to use, right, that are in T, right? So we could come here and pick a table, and it's just going to be 2 by, I'm guessing, 4, like so. Okay, let's make it a bit smaller, like so, and then come here and, okay, can we put them side by side? Okay, let's just put it below it, right? And we have another one, we need another one. We could have a 2 by 4, 2 by 4, like so, right? And we also make it a bit, okay, we also make it a bit smaller, make it around the same size, right? Now this one is going to be we could call it for a sliding window, so we can call it window, like so. And this one is going to be for our T, right? So this can just be T, like so, right? So it's going to be, we're going to have a character here. This is for illustrative purposes, and we're going to have a count, right? So for our window, we are going to have, it's just going to be empty. And what we're going to do in our T is we're going to have all the characters we want, right? The characters that are required and their count, right? So for our character, for T we have A, and A's value is going to be a count of 1. B's value is going to be a count of 1. C's, capitalized C's value is going to be a count of 1, right? And after that, we're just going to loop through S and find how many and try and locate the values in S. So we're going to start off with 2 pointers, and we are going to go through S and see if we can find the characters that are in B, are in T, in S, right? So that's what we do. We start counting through our various characters, and we start with the first character of this Adobe code bank, right? And we check whether the first character is equal to any of these characters. It's A, right? So we have A here, and we increment the count by 1. So our pointer is going to be at A, so our count is 1, and we check are these characters here going to be equal to the characters here? Like, is A equal to A? And the answer is yes. A1 is going to be equal to A1, right? So we have 1. We can increase our halves by 1, and we compare the halves by the need, right? Are the halves equal to the need? Have we found all 3 characters? And the answer so far is no. So we continue. We go to D. We are not interested in D because there is no D in our T string, right? And we go to O, and we go to B, and now we find another character. B is present in the T string, right? So include B in our hash map or dictionary, and we increase the count by 1, right? And we continue to E, and we go all the way, and we increase our halves by 2, of course, right? And we check, is 2 equal to 3? And the answer is no. Remember, 3 is the length of the T string, right? So we continue and we get to C, right? So we get to C when we capitalize it. When we get to capital C, right? So capital C is going to be equal to 1, and we check whether this and we also increase our halves, right? Because C is present in the T string, right? So we compare, are the halves we have greater than the needs? And the answer is greater or equal to, and the answer is yes, right? So basically what we do in this situation, when we get it, we create we could create a variable that can hold our result. Our result is going to be from index 0 to 5, and the length in this situation is going to be 5 plus 1 is going to be 6, right? So the length is going to be 6, right? So we have found one possible answer, but the question we need to ask ourselves, is this the smallest or shortest possible answer? Because we want the minimum window substring, right? So this might not be the minimum. So but we record it and then we continue from there. We are trying to find the minimum. So we begin by moving our left pointer. We have a pointer right now. Our pointer goes all the way from the 0th index to the first index to the 6th index, right? So it's from here to all the way to C here, right? So our right pointer is at, let's put a small r there, and our left pointer is at, let's put it there at L, right? Now we are trying to, since we're trying to find the minimum, we should shrink this we should shrink the window to see whether or not the conditions are still met, right? So we move the left pointer from L and we put it on D, and when we put it on D, we notice that our conditions are not met, right? So now we don't have, the number of A's goes down by 1, so this one will be, the count will be 0, so this, and the halves will be 2, right? So this condition is not met, but we continue, right? Because we have saved one possible answer. We're trying to get to the end of the string and see whether we or not we'll still have an answer. So we go to, from D we go to O, we don't care about O, and then we get when this condition is not met, what we do is we increase the right pointer, right? The right pointer is at C, right? So we increase the right pointer until the condition is met again, and then we move the left pointer, right? So in this case, we go to O, and we don't care about O. We go to D, we don't care about D. We go to E, we don't care about E. Remember, our left pointer is at D right now. So we go to we were at E, we go to B, right? So we have found another character which is available in our string, right? So we increase the number of B's by 2, but we don't increase our halves. And the reason we don't increase our halves is because we have not yet met the condition for A. What we are looking for currently is the number of A's. They have to be equal to the number of A's in the character, in the T string, right? In the T string, right? So now we have it at B, right? Our right pointer was at B. Now we move our right pointer to A, right? So now we have an A, right? And we can increase the count of A by 1, right? Because our string goes all the way from D to A in this code, right? Now we have a possible answer. But the problem with this possible answer is that it is longer than our currently than what we have currently found, right? So we should get something a bit shorter. And like we did previously, when we get when we get a possible string, when the halves, and we need to increase the halves, of course, when the halves equal the needs, right? We have a string that contains all the characters we require. What we need to do is move the left pointer to see that if we can shrink it and still contain all our characters, right? Like we're trying to remove the unnecessary characters. That's basically what we're going to do, right? So what we do here is we move the L, and we move it to O, and we move it to we remove O, and we remove B, right? And we come to E, right? And we have our left pointer here, right? And now that we've removed B, we can remove the count by 1. But you should still notice that we have all our characters, right? We still have A, B, and we still have C, right? And we can come all the way to, and then we move it from E, and we move it all the way to C, right? And now we have and we continue moving it until the halves no longer equal the need, right? And we move it from C, we move it to, and when we move from C, we of course reduce the C by 1. So our pointer is at L, is at O, and then we move it to C, right? And our pointer is now at O, right? So our pointer is at O, and now what we need to do is move the other pointer, right? The right pointer. So in this case, since our pointer is here, we move it all the way to N, right? And then finally we move it, and we don't care about N, and we move it to C, right? And when we get to C, now we have our 1 again, right? And now that we have our 1 again, of course you should be noting the length of the possible answers, right? And in this case, our possible answer, when it was going all the way from when our right pointer was here and our left pointer was at C here, it was 7. It was going all the way from 4 to 10, so it's about 7, right? So another possible answer was 7, but we want a length that is shorter than 6, right? So in such a situation, what we do, we could ignore it. We could note it down, but we're going to ignore it in this case because this is just the pseudocode to help us understand, right? So we move our right pointer until we get it all the way to the end of the string, which is C. We move our right pointer here, and then after that we can now start popping off elements, possibly unnecessary elements, from our left pointer. So we move our left pointer, we remove O, we remove D, we remove E, and we get to B, right? So our left pointer is at B, and now we have another possible candidate. We could move our string a bit back to record another possible string. I just realized that there's a string that is shorter than our current string, right? So in this case, another possible candidate is for our result is going to be from string 8, that is E bank, right? So from 8 to 12, and this is going to have a length of the length here is going to be 5. So this is another possible candidate, right? But we can still move in this situation. We still have unnecessary characters, and we can move it. We are supposed to keep moving the left pointer until our condition is not met. In this situation, the condition is met, right? So we move the L from the E and we move it to the B, right? And now we have another possible answer, and we could say another possible result is going to be from 9 to 12, like so, right? And the length is going to be 4, right? This is another possible candidate. And when we move our left pointer, we move it here, we remove the B, and the B now is 0, and our condition is no longer met, right? And our halves are 2 now, and our conditions are not met. These characters here are not equal to the characters in the T, right? So, but now when we try to move our right pointer, which is at C, we have run out of characters. So we have essentially found the most optimum solution, which in this case goes all the way from 9 to 12, and the length is 4, right? So we return our last answer. In this case, we can get rid of, maybe we could cross this 2 out, we could remove this 2 out, and yeah, and our result is going to be 9 to 12, and the length is 4. So basically that is going to be the idea you need to keep track of. There are a number of variables you need to keep track of. We're going to use 2 hash maps, but at the end of the day we're going to solve it in O of n time, which I believe is very important in this case. So now we can do it, we can put it in code, our question, right? So the first thing we do, we check if T is, we sort out the edge case, right? So if T is an empty string, we need to return, if T is an empty string, we need to return an empty string, like so, right? So we have taken care of that edge case, and the next thing we need to initialize our 2 tables, our 2 hash tables, and the count is going to be the count of T is going to be we could set it, and the window, or the, I can't remember what we call it, let's just call it window, right? Our window for our 2 pointers is going to be both of them are going to be empty arrays, right? When we start off, of course, right? And then the next thing we need to do is we need to loop through every character in T, right? For C in T, and what we need to do is we need to set the value in our array, right? We could say count T, and the key is going to be C, that character in particular, and we are going to add 1 plus the current count, right? And we're going to say count T, and we could use the get method. We could say get, and what you're going to do is we're just going to get the value of c, and if it's not there, we're just going to initialize it to 0. Basically that, right? So that's basically what that line does. And afterwards we need the current, a number of the two variables we used, right? We have a have and we have a need, right? And the have is going to start off at 0, and the need is going to be basically the length of the array we are testing, right? The array we want to find, right? So it's just going to be the length of t, right? So we just put the length of t like so. The thing we need to do is we need to initialize our result, right? So we have our results and the length of that result, right? Which we showed in the when we were doing the pseudocode, right? So the result and the length of the result is going to be, so we're going to initialize the result as -1 and -1 like so, and for the length we're going to start it off, and we're going to start it off at float, and this is just going to be infinity like so, right? So we do that, and the next thing we need is a left pointer, and our left pointer is going to be at 0, and afterwards we need to loop through our string array, which we're trying to find the characters, right? So how we would do that is we would just say for r in the range that we're going to look at is just going to be our s like so, right? And we're going to set that character at r that we're looking at is going to be, we're going to put it in a variable called c. We could say c equals s r like so, right? So we put it there, and then we increase it in our window, right? So we put it in our window, and we say window c, and this is just going to be 1 plus, we do the same thing we did here, right? So we initialize it if it's not there, but if it's there we just take the value and we add 1 to it, right? So we say count, no, it's actually window, not count, right? So it's window, spell it correctly, window dot get, and what we want is c, and if it's not there we want to initialize it to 0, right? So basically we do that, and after we've put it in our window, we want to check whether or not to increase our halves, right? So we come here and we loop through, we check, right? We say if c, the character that we're looking at currently, is in our count t, if it's in our hash map of the characters we're looking at, the t, right? And if it's there and it's exactly equal, right? And the character in the window, right? The value is exactly equal, the same as the t, the value at this key, right, on the c, right? So if they're equal, right, what we need to do is we need to increase our halves by 1, right? So in this situation we have found an instance where we can increase our halves by 1. So we could say here, we come and say have, and what we want to do here is just do plus equal 1 like so, right? So we can do that. The thing we need to do is we need to, actually I realized that the length here is supposed to be, the length here should be just the count, right? This should be count t, because one character might be in the count we'll only look at the various keys, right? So for example, maybe in a certain situation one key might have might appear more than once, right? So here it's just going to be the length in such a situation, we're just going to look at the number of keys, right? So that they're the same, right? And the next thing we need to do is we need to check while we need to run a loop while our have is equal to need and move the left pointer up, right? Like we saw in our pseudocode. So we say while have is need, right? We update our result, right? So we check if r if the r minus 1 minus l plus 1 minus l plus 1, we check the length, right? If it is less than our current results dot result, what do you call it, result len, which we set to infinity, right? Guaranteeing this will run at least the first time, right? So if it is, what we want to do is we set our result, right? And our result is just going to be the left pointer and the right pointer. We put the left and the right pointer like so, right? And afterward we calculate the actual length of the result, and we could just say res is going to be what do we call it, res len. We calculate it res len, and res len is just going to be it's going to be exactly the same, right? It's just going to be r minus l plus 1, yeah, like so, like we calculated. So this is going to be the length of our result, right? And in such a situation, we start moving our pointer from the left, and we also start removing, because remember we put everything in our window, right? So we start removing things from our window, right? In order to check whether we can shorten the res len, right? So what we do is we come here and we say window, and the window is just going to be S1, like so, SL, not 1, sorry, SL, the left pointer, right? And what we need to do is we decrease it from the window, right? Because we are going to move our pointer from our left pointer, we're going to move it to the right, right? And now the next thing we need to check is we need to check whether or not the current character we're removing is going to be in our count.t, right? It's going to be in our count, in our count hash map, right? And if it is, of course, we need to decrement our halves, right? So what we do is after we run that code, after we put that line, we just say if the current character we're looking at in L is in the hash map, and we check the value that maybe we have a surplus. Remember, in there's a situation where we might have a surplus, right? So we check whether or not whether it falls below the corresponding variable value in the key value pair of the count, right? So we come here and we say count, and this is going to be just the S and the L, like so, right? And if it does fall, okay, if it does fall below that, what we need to do is we just need to decrease our half by 1, right? Because it's no longer the half, because it's less than 1, right? And afterwards, of course, we need to move our left pointer right, right? So we say L plus equals 1. So we move it up by 1, and then after all this, we get out of our while and we go to our for loop, and what we do is we say we assign the left and right to our, when all this code has run, the while loop is we've gotten out, we set our left and right pointer to our result, right? And then what we need to do is just return. And what are we going to return? We are going to return the string, and we want to go from L, the left pointer, all the way to R. And to do that, of course, because R is not going to be inclusive, we do R plus plus 1, right? So we want all the way from L to R, and we have to check if the number actually exists, right? If the string actually exists in our, if t actually exists in our longer string, right? Because there's a possibility that we might never encounter it, right? So if this is not equal to, if the res len is not equal to the original answer, right, which is going to be float infinity, so you could just copy this, just say copy and say float infinity, like so, right? So basically, else we want to return just an empty string, like so, right? So basically that, check that our count, if we say count here like so, and this is supposed to be count t, just make sure the count t's are correct, and then when we run our code, it's hopefully going to be accepted, and it's accepted, and if we submit it, it's hopefully going to be accepted, and it is accepted. Basically that, right? So our time complexity is going to be O of n, our space complexity, we do create a bunch of things, right? And depending on their length, one of them is going to be as long as the S string, and another one is going to be potentially as long as the S string in case everything goes wrong, right? And our T string is not in our S string, so count T is going to be potentially as long as the window is going to be potentially as long as the S, and and count T is going to be potentially, if the characters are not repeated, going to be potentially as long as the T, right? So those are the space complexities you're going to have to juggle in this situation. Thank you for watching. Subscribe to the channel, and I'll see you in the next video.